Okay, this value is to go through 2022 FTE paper 2. The last video I stopped at 3A. Basically is to find the acceleration or deceleration that is exerted on the craft, which I got is minus 0.3833 by substituting my A equals to V minus U over T. Okay, so with that I can actually find the resultant force that's acting on the craft by using F net equals to MA, and my mass is actually 5 times 10 to the power of 4 multiplied by this value of minus 0.3833. I will get a value of negative 19200 Newton. However, they are asking for the average force, so it must be a value that has no negative sign. We are just asking for the magnitude. Okay, so part B, average force calculated in part A. The X on a spacecraft is directed towards the Earth. So if I were to draw Earth and this is the spacecraft, if you read the question, is actually moving away from Earth, right? It's moving away from Earth. That's why there is a negative value, which means the Earth is trying to pull it back. So they want us to state and explain the origin of this force. Okay, the force is actually the gravitational force, and it originates from the attraction between the mass of the Earth and the mass of spacecraft, right? Or is due to the gravitational field of the Earth, or due to Earth's gravitational field strength at a point. So state clearly the other force as an action-reaction pair with the average force in part A. In part A, the force, the Earth is exerting a force downwards on the craft towards Earth. Okay, so that means the action-reaction force is that the craft is also exerting a force of equal magnitude but opposite in direction. Okay, and it must be exerted on the opposite body, which is on Earth. So you need to write this down. Okay, so the answer is the gravitational force, because it's the same type of force by spacecraft on Earth. So it is exerted on Earth. Okay, it is a gravitational force because it must be the same type of force, and the force must be equal in magnitude but opposite in direction. Okay, so these are the 4 characteristics of action-reaction force. Okay, question 4. Skydiver jumps from a stationary hot air balloon several km above the ground in terms of acceleration and forces. So we need to answer in terms of acceleration and forces. Explain the motion of the skydiver immediately after jumping. Okay, the answer is this. Immediately after jumping, the only force acting on a skydiver is weight. That means it will skydiver will experience a resultant force. Okay, a resultant force. And this resultant force is actually having the acceleration of g of 10 meter per second square. Okay, so this is, if I were to draw the skydiver, there will only be a force called weight. Okay, and that makes weight the resultant force. Then if there's any resultant force, because F net equals to MA, right, or W equals to mg, therefore the weight will bring about this acceleration due to g, and g has a value of 10 meter per second square because it's happening on Earth. So the next question is also in terms of acceleration of forces, explain the motion of the skydiver at a time before terminal velocity is reached. So before terminal velocity, okay, what is terminal velocity? Terminal velocity means it's the maximum constant velocity. Okay, that means there is no F net. There's no longer going to be any F net, but they wanted a time before terminal velocity is reached. Okay, that means when the skydiver falls, continue falling, there is still a constant weight acting on him. However, as he's falling through air, there will be air resistance. So this air resistance will actually increase with increasing velocity. As your velocity increases, the air resistance will increase. Okay, but this air resistance is actually still, at this point in time, the air resistance is still smaller than weight. That means there is still a small F net or resultant force. Okay, so he will actually experience a small acceleration. Okay, he's still not reaching terminal velocity yet, because that's what the question says. So let's look at the answer. The air resistance acting in the opposite direction to weight increases with velocity. So this is something that you need to know. Okay, and therefore reduces the net force acting on a skydiver. Therefore my F net now is due to W minus AR. W minus air resistance. The weight is constant. Air resistance will increase as the velocity increases. So my F net will actually become smaller. But however, if there's still F net, there is still acceleration. But because my F net now is smaller value, my acceleration is now a smaller value. As a result, the skydiver accelerates downwards with an acceleration less than g or less than 10 meter per second square. So initially was 10 meter per second square, but when velocity increases, air resistance increases, F net decreases. But if F net decreases, there's still F net, just that the acceleration is now a lesser value than 10 meter per second square. Okay. Then we go to the last part. When terminal velocity is reached, that means there is no F net. It has reached the maximum downward velocity. Okay, so in this case, if there's no F net, it means my AR will continue to increase until it is equal to the weight, right? Because previously there was a small acceleration, that means the velocity will continue to increase. So it will increase, and therefore air resistance increases with velocity increasing. It will reach a point whereby your air resistance is equal in magnitude but opposite in direction to your weight. Therefore, there's no longer a F net, therefore no acceleration, and that's why he reaches terminal velocity. Because the question specifically asks for in terms of acceleration and forces, you need to analyze in terms of forces and therefore the acceleration. Okay, so figure 4.1 shows a graph of the variation of the velocity of the skydiver with time. State how the graph will differ for a more massive skydiver of the same size. Okay, the skydiver with a larger mass will take a longer time to reach a terminal velocity, and the terminal velocity will be of a larger value. Okay, his terminal velocity will be a larger value. So this is the reason. This is what will get you your 2 marks. But the reason is with a larger weight. Okay, just now my weight was like that, right? With a larger mass, the weight of this skydiver is larger. So previously, with this amount of air resistance, is able to reach the terminal velocity. But when this guy, let's call it A, when A has reaches terminal velocity, which means F net equals to 0, okay, B still have F net, okay, which is actually W minus AR. B still has F net. Okay, and if there's still F net, that means the skydiver B with a larger mass has not reached terminal velocity yet. So he will continue to accelerate. Okay, he will continue to accelerate. So it will be a while later before his air resistance is enough to be equal to the weight to result in no F net. Okay, so by that time, the terminal velocity has already increased. So he will actually have a larger terminal velocity than skydiver A. Okay, question 5. It shows a wooden block of cross-sectional area A and height H1. Density of the block is density 1, rho 1. The block is placed in water of density rho 2. So block is density 1, water is density 2, rho 2. It floats in equilibrium where the immersed depth is H2. Okay, so we have a few values here that you need to distinguish. State what is meant by the block floats in equilibrium. Okay, when something is in equilibrium, there's no net force acting. Okay, in this case it's the block, so there's no net force acting on the block. All forces acting on the block are balanced, okay, in any directions. Okay, but we also need to take note that there's no net moment. So in equilibrium actually covers two things. F net is 0 and net moment is also 0. Okay. Now state what is meant by the mass of the wooden block. This one you should know. It is the amount of substance in the block. Okay, let me show you the answer. Okay, it's a measure of the amount of substance in the block. Okay. Now state the mass of the wooden block in terms of the given symbols. So what are we given? We are given H1, we are given A. With this, we can actually find volume of the block. And since density equals to mass over volume, so I'll have rho 1, which is density of the block, equals to mass of block over volume. Volume, we can use H1 multiplied by A. So therefore, mass of block is equals to rho 1 A H1. Take note to include all these values, these numbers, to show that it is actually belonging to the measurement of the block. Okay. Next, state the mass of the water displaced by the block in terms of the given symbols when the block is in the water as shown. So if we look at the water, the amount of water displaced is H2. Okay, it's H2. So this part is actually displaced by the block. Okay, so the volume will then be, this is a cross-sectional area A, right? So the volume will then be rho, area multiplied by H2. Okay, but they want the mass of water displaced. So instead of using this as the so let me do my calculation again. The mass of water displaced, density 2 equals to mass of water over volume of water that was displaced. So mass of water is equal to rho 2 multiplied by the volume of water displaced. Now, what is the volume of water displaced? It is cross-sectional area of the block multiplied by H2, AH2. So your final answer should be rho 2 AH2. Take note to write the number 2. Okay. So given that the mass of the wooden block is equivalent to the mass of the water displaced, determine the ratio of the immersed mass H2 with the height of block H1. Show your working clearly. So the mass is equivalent. That means I need to take my C and D and equate them, right? So I will have rho 1 A H1 equals to rho 2 A H2. Okay. So they want the ratio of H2 with H1. So I need to get it to be H2 over H1. And since the cross-sectional area is the same, I can cancel them. So I have H2 over here, so I bring my H1 over. In the end, I get H2 over H1, and therefore rho 1 over rho 2. Okay, so the ratio will be H2 over H1 equals to rho 1 over rho 2. Okay, use the ratio relationship in part E to estimate the immersed depth of a piece of ice floating in a glass of water, assuming that ice is a cube with sides 3 cm. So this is my ice. The side is 3 cm. It's a cube. Okay. Density of ice, so rho ice, is 917 kg per meter cube. You see that the units are really different, so later we need to do some conversion. Water, raw water, it is 1000 kg per meter cube. We are supposed to estimate the immersed depth of a piece of ice. Okay, so we can actually use the relationship from E, H2 over H1 equals to rho 1 over rho 2. So I let the ice be 1 and water be 2. Okay, so H2 becomes H water, the height of the water that the ice is submerged in. H1 is the height of the ice, okay, which is 3 cm, equals to rho of ice over rho of water. Okay, so this is what I want to find out, the height of water or the depth. Height of ice is actually 3 cm. So just now I was saying that the units were different because this is cm, but after that there is meter cube here. However, because we are doing a ratio, so my rho of ice is 917 kg per meter cube. It can actually cancel out with the 1000 kg per meter cube. So there's no need for me to change the cm to SI unit. Okay, because in the end later what I'll get for my H water, the height of water, is actually in cm. You'll get 2.75 cm. Okay, so this is the answer. Okay, next, state what is meant by power. Okay, you see that the answer is power is defined as the rate at which work is done or the rate of energy transferred. Okay, because now we cannot use conversion, or the amount of energy transferred, okay, per second. Okay, do you know why rate at which work is done per unit time is not accepted? Because rate already means per unit time. So you are doing work per unit time, so that is not power. Okay, so if you are using rate, you don't use per unit time. Similarly, like velocity is the rate of change of displacement, but you cannot say velocity is the rate of change of displacement per unit time. Okay, then let's go into the calculation. B, an aircraft of mass 1200 kg. Okay, so this is my mass M. It climbs upwards with a constant velocity of 45 meter per second. Alright, so the thrust, we see that it is 2 times 10 to the power of 3 Newton. The rate of increase in height is 3.3 meter per second. So this is in terms of vertical height. So it is increasing by 3.3 meter per second. Okay, that means every second the vertical height increases by 3.3. Okay, by 3.3 meters. Calculate the power produced by the thrust. Now power, if there is actually a constant velocity, okay, then our power, which is actually P, is energy per unit time, right? But or it is equals to work done over time. Okay, but work done is force times distance moved in the direction of the force over time. So if I happen to have constant velocity, okay, and my d over t is actually velocity, then you can convert into this formula, F times v. Okay, so the force is 2 times 10 to the power of 3 Newton times 45 meter per second. Okay, because this is the chapter on energy, so everything needs to be in SI unit, and I do have everything in SI unit over here. Okay, so the power will then be 9.0 times 10 to the power of 4 watts. Okay, determine for a time interval of 3 minutes. So 3 minutes I need to take note, right? It is actually 180 seconds. Okay, the work done by the thrust to move the aircraft. What's the work done? Work done is force times distance moved in the direction of the force, right? Okay, so in this distance, how do I calculate the distance traveled? The force, take note, it is, if I were to draw the plane, it is this way. The force is in this direction, so the velocity or the distance moved in this direction of the force must also be in this direction. Okay, so the distance traveled equals to speed times time, and my speed is 45 times 180 seconds. So my distance traveled is 8,100 meters. Okay, so I will actually have my force, which is still the same force, 2 times 10 to the power 3 multiplied by 8100 meters. I will get a value of 1.62 times 10 to the power 7 joules. How about the increase in gravitational potential energy? Okay, increase in energy of the gravitational potential store. Okay, so for the height, we know that it is increasing by 3.3 meters every second. Okay, now GPE equals to mgh. The mass, did it say anything? Oh, the mass is 1200. So I substitute in. The G is 10. Now the height, okay, they want it during this time interval of 3 minutes. Okay, so just now we were doing height or distance moved equals to the speed times time. The speed at which the height increase is 3.3, right? Because that's how fast the vertical height increases every second. So 3.3 times 180. Okay, so I should get a value of 594 meters. Okay, so we multiply. So this is how much the height has changed over these 3 minutes. Therefore, I'll get 7.13 times 10 to the power 6 joules. Okay, so this is the increase in the energy in the gravitational potential store. So what's the work done against air resistance? Okay, work done against air resistance is actually using the work done by the thrust, because this was actually what the engine produces. Okay, and however, the increase in height wasn't equals to this value. So the work done against air resistance will then be this value minus 7.13 times 10 to the power 6. Okay, so I'll get a value of 9.07 times 10 to the power 6 joules. Okay, so this is the work done against air resistance, because the GPE, the transfer of this energy to the gravitational potential store, wasn't this value. So there must be some work done against air resistance that results in energy that is being transferred to the internal store of the surrounding. Okay, so with this we can actually calculate a value. Okay, question 7, this is actually a manometer. Okay, this device measures the pressure of a gas supply. So the gas supply is here, so every time there is a surface and a pressure acting on it, we will have to draw arrow and indicate. Now this part, there's no air supply or gas supply connected to it, so it must be atmospheric pressure. Okay, and we have a liquid which may be water or mercury or whatever, I don't know. And I noticed that there's a difference in height of 50 mm. Okay, so atmospheric pressure is 10 to the power 5 Pascal, which is actually given 10 to the power 5 Pascal. The pressure of the gas is 400 Pascal greater than atmospheric pressure. So calculate the density of the liquid. Okay, so what is actually the gas pressure? P gas, okay, is then 10 to the power 5 plus 400 Pascal. Okay, but they want us to calculate the density of the liquid, and this difference in pressure, it will actually be reflected in this difference in height. Okay, because this is a part whereby it is same liquid, same level, same pressure. Same liquid, same level, same pressure. Okay, so I know that the difference in pressure over here, it is due to P gas. Okay, and over here, it is due to P atmospheric plus this 50 mm height of the liquid. Okay, so this left hand side is actually equals to P gas, right? And I know that this 50 mm liquid, that's this difference is because P gas is greater than P atmosphere, and we know that the difference is actually 400 pascal, right? It was given. So this 50 mm liquid, how do we calculate the pressure using this amount of liquid? We'll have to use rho g h. Okay, so the h is actually 50 mm. Okay, we have g of 10, right? This is a gravitational field strength of Earth. The h is actually 50 mm, but I need to convert it to SI unit because what is given here for pressure is actually Pascal. Okay, so I need to divide by 1000, and then that what is left unknown is then the density of this liquid. So I do my equation. My density should be 800 kg per meter cube. Okay, because everything must be in SI unit. Now, when the gas supply is connected, the opening of the tube on the left of the device is sealed with a rubber stopper. Okay, then the gas supply is then disconnected. So I explain what happens to the liquid in the device. So if I were to seal it with a rubber stopper, what it means? Okay, so still I explain what happens to the liquid in the device. The stating of what happens to a liquid is that the liquid on the left will go down slightly, while liquid on the right rises slightly. That means the difference in height of 50 mm will become smaller. Why does this happen? It's because because the pressure of the trapped air is now less than P atm. Okay, explanation is like this. When the left side is sealed, the P air plus P liquid is equals to P gas, right? But when gas is disconnected, pressure on the right hand side becomes exposed to P atm. And remember, P gas is actually is more than P atm. So now the right hand side will actually have a smaller pressure, okay, because the P gas is replaced with P atm. Okay, the P gas is replaced with P atm, and P atm is lesser than P gas. Okay, so now I will have lesser pressure over here because it's now P atm. Okay, so the liquid level will fall over here because I don't need such a high liquid level of 50 mm. Okay, together with the air here to be equal to the new pressure that is found here. Okay, so this side will go up by a bit, this side will go down by a bit. Therefore, the liquid level on the left is still higher than the right. Okay, next question. State what is meant by moment of a force. Okay, moment of a force about a pivot, this is important, is defined as the product of the force and the perpendicular distance from the line of action of the force to the pivot. Okay, what's the other definition that we can ask? Is about your principle of moment. So make sure you know the other definition. Now, it shows three forces acting on a rod. By calculating moments about point X, that means this is going to be my pivot. Show that the rod is not in equilibrium when acted upon by these forces. Okay, remember just now we did something like on equilibrium. Equilibrium means F net must be equals to 0. Net moment must also be equals to 0. So if we look at these three forces, 30 Newton is up. We have 20 Newton and 10 Newton going down. Therefore, the net force is 0. But net moment, it is not 0. So it is not in equilibrium. Let us show the working. Okay. So first of all, we need to, the sixth step is where's the pivot. They have already identified X to be at the pivot. Okay, then number of forces is our next step. We have 3 forces, 1, 2, and 3. Okay, so I'm going to use to annotate it this way. Okay, so this is going to be step 1, this is step 2, step 2, step 2. Okay, then if I have 3 forces, that means step 3, I'm going to have 3 perpendicular distance. So this 30 Newton, it is 0.3 meters away. Okay, so this is my step 3 for my 30 Newton to find the perpendicular distance. For my 10 Newton, it is actually 0.20 meters, and this is my step 3. Okay, for 20 Newton, it's actually 0.60 meters, my step 3. Alright, then step 4 is calculate moment. Moment equals to force times perpendicular distance. If I put this side by side, 30 times 0.3, I'll get 9 Newton meters. 20 times 0.6, I'll get 12 Newton meter. Yep. Then 10 Newton times 0.2, I will get 2 Newton meter. So this is my step 4. Okay, step 4, step 4. Right, step 5, I have to assign direction. Okay, with respect to the pivot at X, this will generate, this moment will be a anti-clockwise direction moment. Okay, this will be a clockwise. Okay, this is my step 5, and this will be a anti-clockwise step 5. All right, so what are the sum of clockwise moment? It is 12 Newton meter. What are my sum of anti-clockwise moment? I have 2, 9 plus 2, so equals to 11. So as you can see, this is the clockwise moment, this is anti-clockwise moment. So the net moment is actually 1 Newton meter, 1 Newton meter clockwise. So if there's net moment, that means it is not in equilibrium. This rod will turn in the clockwise direction. Okay, so maybe I just show you the answers. Okay, so taking moments about X, total clockwise moment equals to 12, total anti-clockwise moment is 11. So since clockwise moment is greater than anti-clockwise moment, the rod is not in rotational equilibrium. Okay, it's best that you follow these 6 steps. Always identify where's the pivot, number of forces, then the perpendicular distance of each force to the pivot. Calculate the moment one by one. So if I have 3 forces, I'm going to have 3 moments. Then determine the direction of the moment, and if they are in equilibrium, then sum of clockwise moment equals to sum of anti-clockwise moment. Okay, so part C, figure 11.2 shows a human arm lifting an object. Lower arm is horizontal, center of gravity is 0.150 meters from the elbow joint. Okay, looks complicated. Later we mark out the positions. Weight of the lower arm is 18 newtons. The bicep muscles exert a vertical force F, this one, on the arm. The horizontal distance between the elbow joint and the point of attachment of the muscle to the lower arm bone is 0.04. So it is this. Okay. The weight of the object held in the hand is 30 newtons, this one. And its center of gravity is 0.46 meters from the elbow joint. So everything is from elbow joint, So I will assume step 1, this is going to be my pivot. The elbow joint is going to be the pivot. Okay, because the distance, the perpendicular distance of all the forces are taken with respect to the elbow joint, which is the pivot, yeah? So the perpendicular distance is 0.46 meters. So arm is in equilibrium, that means we can apply principle of moment. But before that, the calculation, we need to state what is meant by center of gravity. Okay, center of gravity is the point where the whole weight of the object appears to act in. Okay, so please memorize this. So we actually have three definitions in moments. So which is moments? You need to know what's a moment. You need to know CG, and you need to know your principle of moment. Okay, so now they ask us to calculate magnitude of force F is 2 marks. So step 1, the pivot is here, right? I'm going to use this diagram to do all my working. How many forces are there? 1 F, 2 30 Newton, and 3, which is my 18 Newton. So this is my step 3. Okay, then step 2, number of forces. I have 3 forces. Step 3, it is to find the perpendicular distance of each force to the pivot. So actually it's given as 0.040 meters for F. You can see from here, the pivot is here. So far we have not covered things like line of action of the force, but I think you need to know that. Line of action of the force, example, like this is my pivot. Okay, I have a force this way. Okay, line of action of the force, you just draw an imaginary line. You just extend the force forward and backwards of the arrow. Okay, so in this case, because my force is slanted, I take a ruler, I will extend this. Okay, now in order to find the perpendicular distance of the line of action of the force, so this is line of action of the force, I need the perpendicular distance, and since pivot is here, this will be my perpendicular distance. So you need to know how to draw the line of action of the force, and then with that you can find your perpendicular distance. Okay, but in this question, figure 11.2, the perpendicular is very straightforward. So for F, I say again, the perpendicular distance is 0.040. For 18 Newton, it is this value, 0.150 meters. I'll write it here. This is step 3 for me. For 30 Newton, it is 0.460 meters. And again, this is step 3. So step 1, pivot. Step 2, number of forces. Step 3, the perpendicular distance of each force. Step 4, I need to find my moment. Okay, moments is actually equals to force times perpendicular distance. So if I put it here, so it will be 30 times 0.46. I'll get a certain value. Give me a second. Okay, I've done my calculation for moment. For force is unknown, multiplied by perpendicular distance of 0.04, I get 0.044 F Newton meter. For the 18 newtons, the perpendicular distance is 0.15, so I get 2.7 Newton meter. For 30 Newton, perpendicular distance is 0.46, so I get 13.8 Newton meter. Okay, so this is my step 4. Alright, if I have 3 forces, then I need to calculate 3 moments. Now, step 5, I have to give direction. So with this pivot at the elbow joint, okay, this will generate a clockwise moment. Okay, so this will also give me a clockwise moment, my step 5. And this will actually give me a anti-clockwise moment. Okay, because it is with reference to the elbow joint as a pivot. And now, they tell us that this is in equilibrium. Okay, the arm is in equilibrium, therefore I can equate my clockwise moment equals to anti-clockwise moment. So anti-clockwise moment, I only have one, which is 0.04 F. Okay, sum of clockwise will be 2.7 plus 13.8. Okay, so I only have one unknown, which is my F. Then my F will be 413 Newton. Okay, so follow the 6 steps, you are sure to be able to solve. Okay, as the lower arm is moved away from the body, okay, the force F exerted by the bicep muscles act at an angle theta to the vertical as shown. Okay, so now we can actually use this to see if you know how to find your perpendicular distance. Okay, the lower arm remains horizontal and in equilibrium. Then explain what happens to each of the following quantities as the angle theta is increased. Okay, so before that, it was vertical. F was vertical. Elbow joint was here. We have a perpendicular distance of 0.04. But now, if F is slanted and this angle is increased, before that, theta was 0. As theta increases, what happens to the perpendicular distance? So in this case, we just use this as an example. Draw the line of action of force F, right? Draw it like that. And since this is the line of action of the force, line of action, I want to find now its perpendicular distance. So this is now my perpendicular distance. Okay. So how is this different from 0.4? 0.04. Okay. Will this be longer than 0.04? Yes, because if I were to so this is actually 0.04. Oh, sorry. If I were to blow it up a bit into a bigger value, bigger diagram. Okay. This is my F. Before that, it was still 0.04, but now this is the new perpendicular distance. New perpendicular distance. And this is the 90 degrees that's formed. Okay. So that means 0.04 is the hypotenuse, which means this new perpendicular distance is actually now smaller than 0.04. Before that, it was 0.04. So now it will be smaller than 0.04, which means as theta increases, okay, perpendicular distance of F will decrease. Okay, so what does it mean? That means my F will now have a smaller perpendicular distance. Perpendicular distance of F will decrease. Okay, that means my F will have to increase, because in order to keep the same moment due to F, the perpendicular distance went down. Therefore, my force will have to be larger. Okay, but I'm not explaining according to a question, so let's go back to the question. Say explain what happens to each of the following quantities as the angle theta is increased. They want us to find the effect on the anti-clockwise moment. Now, who actually exerts an anti-clockwise moment? It's actually due to force F. Okay, so what happens to the anti-clockwise moment? The anti-clockwise moment will actually decrease. Okay. Oh, but they say the lower arm remains horizontal in an equilibrium. Okay, so this is a trick question. The anti-clockwise moment will actually remains the same, because they say that it is in equilibrium. Okay, and since clockwise moments remains the same, therefore anti-clockwise moment must still be the same. Okay, but then something must change, right? Because the perpendicular distance of F to the pivot has decreased, therefore force F must increase. Force F must increase. Okay, I think I just copy the answer. Okay, the perpendicular distance between line of action of F and the pivot shortens, right? I've tried to show it over here. Okay, I hope you understand some part of it, somewhat. Okay, so for the same anti-clockwise moment, because they told us that the lower arm remains horizontal and in equilibrium. Therefore, for the same anti-clockwise moment, which the clockwise moment remains the same, right? Therefore, the magnitude of F must increase. Okay, So this is the end for 2022 FTE paper 2.